Welcome viewers, in this video we will see the solved problem based on the DC transient response of RC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic transient response, DC transient response of RC circuit. We need to see the diagram. So this is a given diagram. The voltage source is available. R and C, resistor and capacitor connected in series. Resistor value is 1 ohm, capacitor value is 5 farad. So this is a transient current, switch is available. The statement of the problem is, for the circuit shown below, the initial charge in the capacitor is 25 microfarad. Before closing the switch, the initial charge available in the capacitor is 25 microfarad. The switch is closed at t equal to 0. Find transient current. Right? Initially 25 microfarad is available in the capacitor. So after closing the switch at t equal to 0, we need to find the transient current, I of t. Right. So in this we are going to apply the Kirchhoff's voltage law, KVL. KVL is nothing but voltage rise equal to voltage drop. This 10 voltage is the voltage rise. Voltage drop is voltage drop across resistor, voltage drop across capacitor. So this 10 voltage equal to voltage drop across resistor is I into R. I is transient current, R is 1 ohm. Drop across capacitor is 1 by C integral I dt. Right? So we will use the KVL later, so that V equal to voltage drop across resistor plus voltage drop across capacitor. So before going to the KVL, we will find the initial charges available. From that we can easily calculate the voltage, initial voltage. Let Q0 is the initial charge on the capacitor, that is given as 25 microfarad, that is 25 into 10 to the power minus 6 farad. So this initial charge and initial voltage on the capacitor is V0 equal to Q0 divided by C. These two values are available, so we can easily calculate V0. V0 equal to 25 into 10 to the power minus 6 initial charge divided by capacitor 5 farad. So it is totally 25 divided by 5 is 5. 5 into 10 to the power minus 6 voltage. So the initial voltage on the capacitor is 10 to the power 5 into 10 to the power minus 6 voltage. Now we'll go to the Kirchhoff's voltage law, KVL. After t seconds of closing the switch, apply the Kirchhoff's voltage law to the circuit. We already discussed voltage rise equal to voltage drop. Voltage drop across resistor, voltage drop across capacitor. I into R plus 1 by C integral minus infinite to t I dt equal to E. Right? I into R value is 1 plus 1 by C. C value is 5 farad. Minus infinite to t I dt equal to 10. E value is 10. So I plus 1 by 5 integral minus infinite to 0 I dt plus 1 by 5 0 to t I dt, that is equal to 10. So minus infinite to t is split into two intervals, minus infinite to 0, 0 to t. This minus infinite to 0 is nothing but a initial voltage. This is nothing but initial voltage V0. This is the normal transient current 0 to t. At t the switch is closed. This is initial voltage. That we already calculated 5 into 10 to the power minus 6 voltage. Here we calculated initial voltage. From initial charge and capacitor value we calculated V0. Now we can replace this term with 5 into 10 to the power minus 6 voltage. Now we will go for further simplification. So we will substitute this 5 into 10 to the power minus 6 initial voltage. So I plus 5 into 10 to the power minus 6 plus 1 by 5 integral 0 to t I dt equal to 10. So I plus 1 by 5 integral 0 to t I dt equal to 10. This term is brought that side. So 5 into 10 to the power minus 6. So while simplifying we got 9.99. Now we need to take the Laplace transform on both the side in order to find the transient current. Right? First we will take Laplace, then we will take inverse Laplace, so that we will get the transient current. So taking Laplace transform on both the side. So in Laplace of I is I of s. The t domain now converted into s domain. Then 1 by 5 integral 0 to t I dt. The Laplace is I of s divided by s. The Laplace of di by dt is s into I of s, differentiation. Integral means I of s divided by s. Similarly, constant 9.99 means 9.99 divided by s. That is the Laplace transform. Now we'll go for the further simplification. So take this I of s outside. So it become 1 plus 1 divided by 5s, 5 into s. That is equal to 9.99 divided by s. Bring this term in the denominator, that side. 9.99 divided by s into 1 plus 1 divided by 5s. Multiply this s inside. So s into s plus s into 1 by 5 divided by s. This 5 s got cancelled. Right. So what we have finally, it is 9.99 divided by s plus 1 by 5. So 1 divided by 5 is 0.2. So finally we got 9.99 divided by s plus 0.2. Now by taking the inverse Laplace, we can find the transient current. Transient current in the circuit. So I will take the inverse Laplace on both the sides. I of t equal to this 9.99 is available. 1 divided by s plus 0.2 can be written as e power minus 0.2 into t. That is based on this in Laplace inverse of 1 divided by s plus a is nothing but e power minus at. Here plus means minus, minus means plus. So this a is nothing but here 0.2. So that e power minus 0.2 t. So the transient current I of t equal to 9.99 e power minus 0.2 t. So in this video we discussed the solved problem based on the DC transient of RC circuit. We calculated the transient current in the circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.